Suppose we are working in a universe. Um, let's make a drawing of a universe, as we always do. Um, and let's say that in this universe we have certain sets. Let's pick a few of them. So suppose we have 1, 2, 3, 4, and 5, and 6, and 7 elements. Sets in that universe. Uh, let's give names to each of them. So let this be A, and let this be B, C, D, E, F, and G. So at this point, we don't know exactly what the elements of each of these sets are. Let us include some of that information. For example, let us say that the sets D and D together, the collection of these sets, so if I make a grouping of it like this, that is the set A. So here we bring in the following terminology. When we have a certain collection of objects that constitutes the collection of all elements of a given set, we say that that collection forms a set. So in this case, we can say that the collection consisting of D and E forms a set. Namely, it forms the set A. And so the set A is then called a set formed by the collection. The set A is the set formed by the given collection. So the new terms here are collection forming a set and a set formed by a collection. So let's look at other examples on the same display. For instance, we could take the set B to consist of C, F, and G as its elements. So then the collection CFG forms a set, and B is the set formed by that collection. So there is a distinction between collections and sets because not every collection is going to form a set. Let us make that evident by making explicit what the elements of D, E, C, F, and G are. So let's say D is actually a set whose elements are F and E. And we can mark that with a different color. I'm going to use the green color for that. And suppose E is a set whose elements are C and G. And suppose so the two other sets remain to be specified what their elements are in this display. It's F and C. So let's say F is the empty set, a set having no elements. And let's say that C is a set having, well, actually also G has to be specified. So C is a set having G as its element. So it only has one element, and that's G. And now I'm running out of colors here, so I'm going to use oh, I can get more colors from here. That's great. What color should we use for G? Let's use something like that. So I mean for C, so that's the set C. And let's say G is a set having as its element let's go back here. Let's say G has A as its element. And we will need another color for that. So just pick a random color. Oops. So there we go. So that's the set G. And so here now we have several instances of certain collections forming sets, like the collection consisting of just the set A forms a set, and so does the collection consisting of just the set oops, there. I'm trying to get that space filled with the color, otherwise it is red inside. Oh no, it's not working. Definitely not working. Okay, one last try and then I'm gonna give up on this. No. Okay. Oh, I actually did manage to do that in the previous case. Okay, great. So we've got the collection consisting of A that forms a set. And the set formed by that collection is the set G. And we also have a collection consisting just of G forming a set. And the set formed by that collection is the set C. And now the purple collection here that forms a set, it's the set E. The green collection that forms a set, it's the set D. The yellow collection that forms a set, it's the set A, and so on. But we also have a bunch of collections that do not form sets. For instance, we can see here that the collection consisting of, let's say, B, D, and E does not form a set. There is no dot in the universe that expands into this content. So that makes it clear that there is a difference between a set and a collection, right? So we can have collections that do not form sets, but certain collections do. And that's why we need the terminology of forming a set to identify which collections appear as sets in the universe and which do not. Of course, on this example, we have many other collections that do not form sets. For instance, we could take the collection just consisting of just B that also does not form a set. And many more. In fact, there are more collections here that do not form sets than those that do form sets.